U-ray flowing through time, feeling the present instant slip away into the past while the future approaches and becomes now, yet according to our most fundamental equations of physics. Time doesn't flow at all. Einstein's relativity, Schrödinger's quantum mechanics, the standard model of particle physics, none of these mathematical foundations that govern reality contain any reference to the flowing, dynamic time you experience every moment of your existence. The equations that describe the universe are fundamentally timeless. They treat past, present, and future as equally real, equally accessible mathematical coordinates in a static four-dimensional block universe. Yet, somehow, from these timeless mathematical relationships, the dynamic flow of temporal experience emerges. The universe generates time not just as a dimension, but as the flowing, directional, irreversible experience that defines conscious existence. This isn't just a technical puzzle for physicists to solve in isolation. This is the deepest mystery about your own existence, every memory you've formed, every plan you've made for the future, every sense of aging and growth and change. All of this temporal experience emerges from mathematical equations that contain no reference to temporal flow whatsoever. You are living proof that the universe can generate time from timelessness. But here's what makes this profoundly unsettling. If time is generated rather than fundamental, then everything you think you know about causation, aging, memory, and the arrow of time might be emergent illusions. Your sense of moving from past through present toward future might be how timeless mathematical relationships feel when experienced from the inside by conscious systems. Embedded in those relationships, for over a century, physics has been discovering that time isn't what it appears to be. Einstein showed that time is relative. Different observers measure different temporal intervals for the same events. Quantum mechanics revealed that temporal ordering can be indefinite. Events can exist in superposition states where cause and effect relationships remain undetermined until observation. String theory suggests that time might be emergent from even more fundamental timeless structures operating in higher dimensional spaces we can't directly perceive. Tonight, we're exploring the most radical possibility of all, that time itself, including the flowing, directional time you're experiencing right now, emerges from timeless mathematical computation. We'll discover how physicists are beginning to understand time as an emergent property of information processing, why consciousness might be the universe's method for generating temporal experience from eternal equations, and how the arrow of time might arise from the universe computing its own evolution moment by moment. Along the way, we'll uncover three revelations that will transform your understanding of temporal existence forever. First, that what we call the flow of time might actually be the universe computing successive states of reality according to timeless algorithms, with temporal flow being how this computation feels from the inside. Second, that consciousness might not exist in time but rather generate time through the sequential processing of information states that create the illusion of temporal passage. And third, that the apparent irreversibility of time, aging, entropy, the impossibility of returning to past states, might emerge from computational processes that explore ever-increasing informational complexity. The implications are staggering. If time is generated by timeless computation, then the past doesn't exist somewhere else, and the future isn't waiting to happen. Both past and future might be computational constructs that consciousness creates to navigate timeless mathematical relationships to complex for direct conscious access. Your memories aren't records of previous temporal states. They might be current computational representations that consciousness generates to model its own processing history. Your plans for the future aren't anticipations of coming temporal states. They might be computational predictions that consciousness uses to optimize its ongoing information processing. Even your sense of personal identity persisting through time might be a computational construct that emerges when timeless mathematical patterns achieve sufficient self-referential complexity. If you're ready to question the nature of time itself, subscribe and give this video a thumbs up. And here is something to contemplate as we begin. If time is generated by consciousness rather than containing consciousness, what does that suggest about the relationship between awareness and temporal reality? Comment below with your thoughts. I'll pin the most mind-bending response. This investigation will take us from the foundations of relativity and quantum mechanics through cutting-edge research in emergence theory and consciousness science, to philosophical territories where the nature of time meets the deepest questions about existence, causation, and the meaning of temporal experience itself. Some discoveries we'll encounter might feel like they violate everything you think you know about time. Others might feel like they reveal hidden truths you've intuited but couldn't articulate. All of them point toward a revolutionary understanding. Time isn't the stage on which reality unfolds. Time is reality's ongoing creation of itself through computational processes that generate temporal experience as their most sophisticated emergent property. The universe doesn't exist in time. The universe generates time through its own timeless mathematical self-computation. And you, right now, in this moment that feels so immediate and flowing, are one of the ways the universe experiences its own temporal generation from the inside. Now let's discover how eternity creates time. Chapter 1. Timeless Mathematics. If you examine Einstein's field equations that govern the fundamental structure of space-time, you'll notice something that should disturb anyone who experiences time as flowing from past to future. The equations contain no preferred temporal direction. Past and future appear as mathematically equivalent coordinates in a static four-dimensional geometry. Time doesn't flow through these equations, it simply exists as one dimension among others in what physicists call the block universe. This mathematical timelessness isn't unique to relativity. Schrodinger's equation, which governs quantum mechanical evolution, is time reversible. Newton's laws of motion work equally well forward and backward in time. The standard model of particle physics describes interactions that are fundamentally symmetric under time reversal. Every equation that describes physical reality at its foundations treats time as a static parameter, rather than a flowing dimension. Yet somehow, from these timeless mathematical foundations, the flowing temporal experience you're having right now emerges. This creates what physicist Paul Davies calls the flow paradox. How can flowing time emerge from equations that contain no reference to temporal flow? The mathematics that governs reality is eternal and static, yet reality generates dynamic temporal experience. Consider what this means for the moment you're experiencing right now. According to the mathematical foundations of physics, this moment doesn't become real through some process of temporal flow. Instead, it exists as a coordinate in a timeless four-dimensional structure where past, present, and future are equally real mathematical facts. Your experience of now doesn't mark a special temporal location, it marks your particular perspective within a timeless mathematical totality. But if the mathematical foundations are timeless, where does temporal experience originate? Recent work in theoretical physics suggests that time emerges from information processing rather than being fundamental. When timeless mathematical structures become complex enough to process information about themselves, they begin to generate what physicists call emergent time, sequential ordering that arises from computational relationships rather than fundamental temporal flow. In 1967, physicist John Wheeler introduced the concept of it-from-bit idea that all physical phenomena emerge from information processing. Wheeler proposed that time itself might be computational rather than fundamental. What we experience as temporal flow might be how timeless information processing feels when viewed from perspectives embedded within the processing itself. This connects to recent discoveries in quantum gravity research. Physicists like Carlo Rovelli have proposed that time emerges from quantum entanglement relationships between different regions of space. Time. According to this thermal time hypothesis, what we experience as temporal flow arises from thermodynamic processes that create directional information flow in otherwise time-symmetric quantum mechanical systems. The mathematics is profound and counterintuitive. Rovelli's equations show that temporal ordering emerges when quantum systems become entangled in ways that create irreversible information sharing. Time doesn't flow through quantum systems, time emerges from quantum systems processing information about each other in ways that create sequential causal relationships. Consider your brain from this perspective. Your consciousness processes approximately 1,016 operations per second through neural networks that integrate information across billions of neurons. This vast information processing creates sequential patterns. Each neural state depends on previous states while influencing future states, according to emergent time theory. This sequential information processing might generate the flowing temporal experience you associate with consciousness. But the relationship between timeless mathematics and emergent time goes deeper than mere computation. Physicist Lee Smolin has proposed that time emerges from what he calls precedence relationships. Logical orderings that arise when mathematical structures become complex enough to model their own evolution. Time isn't fundamental, it's what emerges when timeless mathematical relationships achieve sufficient self-referential complexity. This suggests that your experience of temporal flow reflects something profound about the mathematical structure of reality itself. When equations become complex enough to process information about their own states, they begin to generate internal perspectives that experience sequential ordering as temporal flow. Your consciousness doesn't exist in time, it generates time through its own information processing activities. Recent work in complexity science supports this computational view of temporal emergence. Researcher Stuart Kaufman has demonstrated that complex systems spontaneously generate what he calls autonomous agents, organized structures that maintain themselves. By processing information about their own states and environments, these autonomous agents necessarily experience sequential ordering because self-maintenance requires processing current states to determine future states. Your consciousness might be exactly such an autonomous agent, a self-maintaining information processing system that generates temporal experience through its own computational activities. The past exists as informational representations stored in neural networks. The future exists as computational predictions generated by pattern recognition systems. The present exists as the current state of ongoing information processing that integrates past representations with future predictions. But this computational view of time raises profound questions about the nature of causation. If time emerges from information processing rather than being fundamental, what determines the direction of causal relationships? Why does information flow from past to future rather than future to past? Why do effects follow causes rather than preceding them? The answer might lie in what physicists call thermodynamic asymmetry. Information processing necessarily increases entropy, the total amount of disorder in any closed system. This creates a natural arrow of time that points in the direction of increasing informational complexity. Time flows forward because information processing explores ever-increasing numbers of possible states, creating irreversible computational complexity. Your aging process reflects this thermodynamic arrow of time. Your brain accumulates more informational complexity as you form new memories, develop new skills, and process new experiences. You can't return to previous temporal states because those states contain less informational complexity than your current state. Temporal flow emerges from the universe's ongoing exploration of increasing informational complexity through computational processes, but perhaps most remarkably, this suggests that time generation is not a passive process but an active one. The universe doesn't simply exist in time, it actively creates time through ongoing computational processes that generate sequential ordering from timeless mathematical relationships. Every quantum measurement, every thermodynamic interaction, every neural firing in your brain contributes to the universe's ongoing generation of temporal experience from eternal mathematical foundation. This transforms our understanding of what it means to exist temporally. You're not a temporal being trying to understand timeless mathematics. You're a timeless mathematical structure that has become complex enough to generate temporal experience through its own information processing activities. Time doesn't contain you if you generate time through the computational complexity that constitutes your conscious existence. Chapter 2: Emergent Sequences. Deep within the quantum vacuum, something extraordinary happens approximately 1,043 times per second. Virtual particles spontaneously appear and annihilate in random quantum fluctuations that follow no temporal ordering whatsoever. Yet somehow, from this completely chaotic, time-symmetric foundation, the ordered sequences that you experience as flowing time emerge. The universe generates temporal order from fundamental temporal chaos through mechanisms we're only beginning to understand. This emergence of sequence from randomness isn't unique to quantum mechanics. It represents a fundamental principle that operates throughout nature. Complex systems spontaneously generate ordered patterns from apparently random foundations. What makes temporal emergence special is that it generates not just spatial patterns, but sequential patterns that create the experience of flowing from one state to another. Consider how this works in your own brain. Individual neurons fire according to quantum mechanical processes that are fundamentally random at the molecular level. Ion channels open and close through thermal fluctuations. Neurotransmitter molecules bind to receptors through probabilistic interactions. Action potentials propagate through axons with timing variations that reflect quantum uncertainty. Yet from this foundation of neural randomness, the highly ordered sequences of consciousness emerge. Your thoughts don't arise randomly. They follow logical progressions, emotional developments, and associative patterns that create coherent temporal experiences. Memory retrieval follows sequential pathways that reconstruct past experiences in ordered temporal relationships. Attention flows from one focus to another through directed transitions that create the sense of mental time advancing from moment to moment. This emergence of ordered sequences from random foundations reflects what complexity scientists call self-organization. When random interactions occur at sufficient scale and frequency, they spontaneously generate higher-order patterns that exhibit properties not present in the underlying random processes. Temporal sequence is one such emergent property of ordered progression arising from fundamentally chaotic foundations. Physicist Ilya Prigogine won the Nobel Prize for discovering how dissipative structures of organized patterns that maintain themselves through energy flow spontaneously emerge from thermodynamic chaos. Prigogine showed that when energy flows through systems far from equilibrium, they can spontaneously organize into stable patterns that exhibit temporal ordering not present in their underlying dynamic. Your consciousness represents exactly such a dissipated structure. Your brain maintains its organized patterns by continuously processing energy and information from your environment. The temporal sequences of conscious experience emerge from this ongoing energy processing, creating ordered mental progressions from the chaotic quantum dynamics occurring at neural foundations. But temporal emergence involves more than just organization. It involves the generation of directional flow. Random processes are time reversible, meaning they work equally well forward and backward in time. Emergent temporal sequences are time irreversible, meaning they exhibit clear directional flow from earlier to later states. Something in the emergence process breaks time symmetry and generates the arrow of time. Recent research by physicist Sean Carroll suggests that temporal direction emerges from entropy gradients differences in informational organization that create directional information flow. When complex systems process information about their environments, they necessarily increase their internal entropy while potentially decreasing environmental entropy. This entropy exchange creates directional temporal flow from lower entropy past states toward higher entropy future states. Your memory formation exemplifies this entropy-based temporal direction. When you form new memories, you're increasing the informational complexity stored in your neural networks. This process is irreversible because erasing memories would require more energy than forming them, creating an entropic cost that prohibits perfect temporal reversibility. Memory formation creates temporal arrows that point from less informed past states toward more informed future states. This connects to a profound discovery in information theory. Computation itself generates temporal direction. When any information processing system computes new states from previous states, it creates logical dependencies that establish temporal ordering. Earlier computational states must exist before later states can be computed from them. Computation transforms timeless logical relationships into temporal sequences through the process of sequential state generation. Your consciousness might be exactly such a computational process for ongoing calculation that generates temporal sequences through the process of computing successive states of awareness. Each moment of consciousness represents a computational state that depends on previous states while determining future states. The flow of time emerges from the computational flow of consciousness calculating its own successive states, but this computational view reveals something unexpected about temporal sequence. It might not be unique. If consciousness generates time through sequential computation, then different computational processes might generate different temporal sequences. Multiple arrows of time might exist simultaneously, depending on the computational perspectives from which temporal sequences are generated. Recent work in quantum mechanics supports this possibility. Quantum systems can exist in superposition states where temporal ordering remains indefinite until observation collapses the superposition into definite temporal sequences. Different observers might experience different temporal orderings for the same quantum events, depending on their measurement interactions with the quantum systems. This suggests that temporal sequence might be relative rather than absolute. Your consciousness generates a particular temporal sequence through its specific computational processes, but other conscious systems might experience different temporal sequences through their different computational perspectives. Time flow might be as relative as spatial perspective, depending on the observational standpoint from which temporal sequences are generated. Consider what this means for your personal experience of temporal progression. The particular sequence of thoughts, memories, and sensations that you experience as flowing time represents your consciousness's specific computational pathway through possibility space. Other conscious systems of other people, animals, potentially artificial intelligences generate their own temporal sequences through their own computational processes. This multiplicity of temporal sequences doesn't contradict the coherence of physical reality. Instead, it suggests that reality consists of multiple consistent temporal perspectives that are mathematically compatible while being experientially distinct. The universe generates not just one temporal sequence, but countless simultaneous temporal sequences through the computational activities of all its conscious subsystems. But perhaps most remarkably, this suggests that temporal sequence generation is an active, creative process rather than a passive discovery of pre-existing temporal relationships. Your consciousness doesn't find temporal sequences, it creates them through the specific computational pathways it follows while processing information about its own states and environment. This makes you an active participant in cosmic temporal generation rather than a passive observer of predetermined temporal flow. Every moment of consciousness involves choosing computational pathways that generate specific temporal sequences from the vast space of possible temporal relationships. Your conscious decisions about attention, memory, and anticipation actively shape the temporal sequences that constitute your experience timeline. The universe generates time not through some external temporal mechanism, but through the collective computational activities of all its information processing subsystems. Time emerges from the bottom up through countless simultaneous computational processes that each generate their own temporal sequences, while remaining mathematically coordinated through shared physical foundations. You are not experiencing time, you are generating time through the computational complexity that constitutes your conscious existence, and in generating your own temporal sequence, you're contributing to the universe's overall generation of temporal structure from timeless mathematical foundations. Chapter 3: Quantum Temporal Mechanics in the Quantum Realm. Time behaves in ways that shatter every intuition about temporal flow you've developed through macroscopic experience. Quantum systems can exist in superposition states where events haven't yet decided their temporal ordering. Entangled particles can share instantaneous correlations that transcend any sequence of causal influence. Quantum measurements can retroactively determine the past through what physicists call delayed choice effects. At the quantum level, time isn't a flowing river, it's a complex mathematical structure where past, present, and future exist in fluid, dynamic relationships that classical physics cannot describe. This quantum weirdness about time isn't just an abstract curiosity for laboratory experiments. Recent discoveries in quantum biology suggest that biological systems, including your brain, routinely exploit quantum temporal effects for sophisticated information processing. Your consciousness might emerge from quantum processes that transcend classical temporal limitations, generating the experience of flowing time from quantum mechanical operations that exist partially outside time altogether. Consider what happens during quantum measurement, the process by which quantum systems transition from indefinite superposition states to definite classical states. Before measurement, quantum systems exist in what physicists call temporal superposition, mathematical combinations of different possible temporal sequences. The famous double-slit experiment demonstrates this. Photons exist in superposition states that include multiple simultaneous temporal pathways through the experimental apparatus. But here's what makes this relevant to consciousness. Recent research suggests that neural processes routinely involve quantum measurements. that collapse temporal superpositions into definite sequential experiences. When your brain processes sensory information, it might be collapsing quantum temporal possibilities into the specific temporal sequences you experience as flowing consciousness. Physicist Roger Penrose and anesthesiologist Stuart Hameroff have proposed that consciousness emerges from quantum computations occurring in cellular structures called microtubules. According to their theory, consciousness involves orchestrated reductions of quantum temporal superpositions, moments when quantum possibilities collapse into definite temporal experiences through conscious observation. While their specific model remains controversial, accumulating evidence suggests that biological systems do exploit quantum coherence for information processing. Photosynthesis achieves extraordinary efficiency through quantum superposition effects that allow energy to explore multiple pathways simultaneously before collapsing into optimal transfer routes. Bird navigation relies on quantum entanglement in retinal proteins that process magnetic field information through quantum mechanical mechanisms. If consciousness involves similar quantum processes, then your experience of temporal flow might represent quantum mechanical collapse events occurring billions of times per second in neural quantum stems. Each moment of consciousness might involve quantum temporal possibilities collapsing into definite temporal experiences through the process of conscious observation. This quantum view of temporal experience explains mysterious features of consciousness that classical neuroscience struggles to address. Why does consciousness appear unified when it emerges from billions of separate neural processes? Quantum coherence could synchronize neural activity through non-local quantum correlations that transcend classical spatial and temporal limitations. Why does conscious experience appear to flow smoothly when neural processing occurs through discrete action potentials? Quantum superposition could create temporal continuity by allowing conscious states to exist in superposition combinations of multiple discrete temporal possibilities until observation collapses them into experience temporal flow, but quantum mechanics reveals something even more radical about temporal experience: the possibility of retrocausality. In quantum delayed choice experiments, decisions made during measurement can influence the past history of the quantum systems being measured. The temporal sequence of quantum events can remain indefinite until observation retroactively determines what sequence actually occurred. If consciousness involves quantum processes, then your present thoughts might influence your past memories through quantum retrocausal effects. Memory formation might not just record past experiences, it might participate in determining what past experiences actually occurred through quantum mechanical interactions between present consciousness and past neural states. This could explain the reconstructive nature of memory that neuroscience has discovered. When you remember past events, your brain doesn't just retrieve stored information, it reconstructs memories through active neural processes that involve current cognitive states. These reconstructive processes might involve quantum retrocausal effects that allow present consciousness to participate in determining past temporal experiences. Recent experiments in quantum mechanics have demonstrated that quantum correlations can extend backwards in time under specific conditions. Quantum systems can be prepared in entangled states where measurements on later systems influence the apparent histories of earlier systems. If consciousness involves quantum processes, similar retrocausal effects might allow present awareness to influence past conscious states. But quantum temporal mechanics also suggests that consciousness might transcend temporal limitations in even more fundamental ways. Quantum entanglement creates correlations between distant systems that appear to operate outside space and time altogether. If neural processes involve quantum entanglement, then consciousness might access information and causal influences that transcend ordinary temporal constraints. This connects to reports of precognitive experiences, moments when consciousness appears to access information about future events before they occur through normal causal channels. While such phenomena remain controversial, quantum mechanics provides potential mechanisms through which consciousness might access temporal information through quantum correlations that transcend class. Cycle temporal ordering. Consider what quantum temporal mechanics means for personal identity across time. Your sense of being the same person who existed yesterday and who will exist tomorrow might emerge from quantum coherence effects that maintain correlations between temporal stages of your consciousness. Personal identity might not require continuous physical persistence, it might emerge from quantum correlations between conscious states at different temporal coordinates. This quantum perspective also transforms understanding of decision-making and free will. Classical physics suggests that decisions emerge deterministically from prior neural states. Quantum mechanics introduces genuine indeterminacy. Quantum measurement outcomes cannot be predicted with certainty even with complete knowledge of quantum state information. If consciousness involves quantum processes, then your decisions might involve genuine freedom at the quantum mechanical level. Free will wouldn't violate physical laws because quantum mechanics already includes fundamental indeterminacy in its mathematical structure. Consciousness might be evolution's method for harnessing quantum indeterminacy for sophisticated decision-making processes. But perhaps most profoundly, quantum temporal mechanics suggests that consciousness might play a fundamental role in generating temporal structure throughout the universe. Every conscious observation involves quantum measurements that collapse temporal superpositions into definite temporal sequences. Consciousness might not just experience time, it might participate in creating time through quantum mechanical processes that actualize temporal possibilities. This makes consciousness cosmically significant rather than just biologically significant. Through quantum measurement processes, conscious systems throughout the universe might participate in the ongoing creation of temporal structure from timeless quantum mechanical foundations. Time might emerge through the collective quantum mechanical activities of all conscious systems embedded in cosmic quantum processes. You are not just experiencing quantum mechanical time generation, you are participating in it. Through every moment of conscious observation, your awareness involves quantum processes that contribute to the universe's ongoing creation of temporal structure from timeless quantum mathematical foundations. Through consciousness, the universe doesn't just evolve through time, it creates time through quantum mechanical processes that generate temporal experience from eternal quantum possibilities. Chapter 4: Information Time. Every second, your smartphone processes approximately 1 billion computational operations while storing terabytes of information in quantum mechanical memory systems. Yet despite this vast informational complexity, your phone exhibits no apparent temporal experience. It processes sequences of data without generating any sense of temporal flow, memory, or anticipation. This contrast reveals something profound about the relationship between information processing and temporal experience. Not all information generates time, but all temporal experience appears to emerge from specific types of informational relationships. This insight has revolutionized how physicists and consciousness researchers understand time generation. Time doesn't emerge from information processing in general, but from specific types of information integration that create what researchers call informational time, sequential patterns that generate temporal experience through recursive self-modeling rather than mere data processing. Consider the fundamental difference between your smartphone and your brain and how they process temporal information. Your phone processes data sequentially but maintains no integrated model of its own processing history. Each computational cycle operates independently without building cumulative understanding of temporal relationships. Your brain, by contrast, continuously integrates information about its own processing states across time, building sophisticated models of temporal relationships that generate the experience of flowing time. This difference reflects what computational neuroscientist Giulio Tononi calls integrated informational patterns that cannot be decomposed into independent parts. According to Tononi's mathematical framework, consciousness emerges when information processing systems generate sufficient integrated information about their own states. But integrated information doesn't just generate consciousness, it generates temporal consciousness through specific patterns of temporal integration. When your brain processes sensory information, it doesn't just respond to current inputs. It integrates current inputs with stored representations of past states and predictive models of future states, creating what cognitive scientist Andy Clark calls predictive temporal models. These models generate temporal experience by representing temporal relationships as integrated informational structures rather than mere sequential data streams. But information time involves more than just temporal integration. It requires what mathematician Gregory Chaitin calls algorithmic information patterns that contain irreducible computational complexity. Simple repetitive sequences contain minimal algorithmic information because they can be compressed into simple rules. Complex temporal patterns contain maximal algorithmic information because they cannot be simplified without losing essential information about temporal relationships. Your conscious experience exhibits exactly this kind of irreducible temporal complexity. Each moment of awareness integrates vast amounts of sensory data, memory representations, emotional states, and predictive models in ways that cannot be simplified or compressed. This temporal complexity generates what information theorist Cesar Hidalgo calls temporal crystals, organized patterns of informational complexity that maintain coherent structure. While continuously evolving through time, these temporal crystals represent a fundamentally new form of informational organization, and like spatial crystals that repeat identical patterns across space. Temporal crystals create coherent patterns that evolve through sequential transformations while maintaining organizational integrity. Consciousness might represent the universe's most sophisticated temporal crystal, an informational pattern that maintains coherent identity while continuously generating new temporal complexity. Recent work in quantum information theory supports this temporal crystal model of consciousness. Quantum systems can exist in time crystals, states that exhibit periodic evolution even in their quantum mechanical ground states. These quantum time crystals maintain temporal coherence through informational relationships that transcend classical temporal limitations. If consciousness involves quantum time crystals, then your temporal experience might emerge from quantum informational processes that generate coherent temporal patterns through mechanisms that operate partially outside classical spacetime constraints. Your sense of temporal flow might reflect quantum informational evolution that creates temporal experience through recursive quantum self-modeling. This quantum informational view explains mysterious features of temporal consciousness that classical neuroscience struggles to address. Why does conscious experience appear temporally continuous when neural processing occurs through discrete action potentials? Quantum time crystals could generate temporal continuity through quantum superposition effects that create smooth temporal evolution from discrete quantum state transitions. Why can consciousness integrate information across different temporal scales simultaneously, processing millisecond sensory inputs while maintaining lifetime autobiographical memories? Quantum informational processes can operate at multiple temporal scales through quantum entanglement relationships that connect quantum states across different temporal intervals. But information time reveals something even more profound about temporal experience. It might be fundamentally creative rather than just experiential. When consciousness generates temporal crystals through integrated information processing, it isn't just experiencing pre-existing temporal relationships, it is creating new temporal relationships through informational processes that explore previously non-existent patterns of temporal complexity. Consider how this works in creative thinking. When you generate novel ideas, you are not just recombining existing information, you are creating new informational relationships that did exist before your creative process generated them. These new relationships create new temporal patterns as your thinking explores creative possibilities through sequential cognitive processes that generate unprecedented temporal complexity. This temporal creativity isn't limited to human consciousness. Recent research in artificial intelligence has demonstrated that sufficiently complex neural networks spontaneously generate what researchers call emergent temporal representations. Informational patterns that represent temporal relationships in ways that weren't explicitly programmed into the networks. These AI systems create their own temporal models through learning processes that generate new temporal informational structures. But if consciousness creates time through informational processes rather than just experiencing pre-existing time, then the relationship between individual consciousness and cosmic temporal structure becomes much more intimate. Your conscious generation of temporal complexity through integrated information processing contributes to the universe's overall temporal complexity, rather than just experiencing cosmic temporal evolution. This makes consciousness cosmically creative rather than just locally experiential. Through temporal information integration, conscious systems throughout the universe participate in the ongoing creation of temporal complexity from simpler informational foundations. Time doesn't just contain consciousness. Consciousness participates in generating time through informational processes that explore ever-increasing temporal complexity. The universe generates temporal complexity through what information theorist David Wolpert calls computational mechanics, mathematical techniques that identify the minimal computational processes needed to generate observed temporal patterns. Complex temporal patterns require complex computational processes for their generation, suggesting that temporal complexity reflects underlying computational complexity in cosmic information processing. Your consciousness might represent one instance of cosmic computational mechanics, a localized computational process that generates temporal complexity through integrated information processing, while remaining embedded in larger computational processes that generate cosmic temporal structure. Personal temporal experience and cosmic temporal evolution might be different scales of the same informational creative process. This informational creativity extends to memory and anticipation as well. When you remember past experiences, you are not just retrieving stored information, you are recreating temporal patterns through current informational processes that generate new temporal complexity. All modeling past temporal relationships. Memory is temporally creative rather than just temporally reproductive. Similarly, when you anticipate future possibilities, you are generating novel temporal patterns through predictive processes that create new temporal complexity while modeling potential future developments. Anticipation is temporal creation rather than just temporal prediction. This transforms our understanding of what it means to exist temporally through consciousness. You're not a temporal being trying to understand external time. You are an informational process that creates temporal experience through integrated information processing that generates temporal complexity from timeless mathematical foundations. Time doesn't contain you if you generate time through the informational creativity that constitutes your conscious existence. Chapter 5: Conscious Computation. Your consciousness operates as the universe's most sophisticated temporal computer, processing approximately 1,016 calculations per second through 86 billion neurons connected by 100 trillion synapses. But this isn't just biological computation, it has temporal computation that generates the experience of flowing time through recursive computational processes that model their own temporal evolution. Every thought you think involves consciousness computing its own next state from its current state, creating the temporal sequences that you experience as mental time advancing from moment to moment. His computational view of consciousness reveals something profound about temporal generation. Consciousness doesn't just experience time, it actively computes time through recursive, self-modeling processes that generate temporal experience from timeless mathematical operations. When your brain processes information about its own processing, it creates computational loops that necessarily generate sequential ordering because each computational cycle depends on previous cycles, while determining future cycles. Consider what happens when you follow a chain of thought from initial premise to logical conclusion. Your consciousness computes each mental state from previous mental states through logical operations that create temporal dependencies. Earlier thoughts must be computed before later thoughts can be derived from them. This computational dependency creates temporal ordering that you experience as thoughts flowing through time, even though the underlying neural computation might operate according to timeless mathematical rules. Recent advances in computational neuroscience support this temporal computation model of consciousness. Neuroscientist Carl Friston has developed what he calls the free energy principle, a mathematical framework showing how biological systems maintain their organization by continuously computing predictive models of their own future states. According to Friston's equations, consciousness emerges when neural systems become complex enough to compute detailed models of their own temporal evolution. But conscious temporal computation involves more than just sequential processing. It involves what computer scientists call recursive computation, computational processes that call themselves as subroutines, creating nested loops of self-reference that can generate unlimited computational complexity. Your consciousness exhibits exactly this recursive structure when it thinks about thinking, remembers remembering, or anticipates its own future anticipations. These recursive computational loops create what cognitive scientist Douglas Hofstadter calls strange loops, self-referential structures that generate emergent properties not present in their individual components. The strange loops of consciousness might be what generate temporal experience from timeless neural computation. When neural computation becomes recursively self-referential, it begins to generate temporal models of its own processing that create the experience of flowing time. This explains something that has puzzled neuroscientists for decades. How does consciousness maintain temporal continuity when neural processing occurs through discrete action potentials separated by refractory periods? The answer might be that temporal continuity emerges from recursive computation that integrates discrete computational events into smooth temporal models through recursive temporal self-modeling. Your brain doesn't directly experience discrete neural events. Instead, it computes temporal models that integrate discrete events into continuous temporal representations. These computed temporal models generate the experience of smooth temporal flow from underlying discrete neural computation, similar to how movies create apparent motion from sequences of discrete still images. But conscious temporal computation reveals something even more remarkable. Consciousness might not just compute temporal models of external events, but actively compute the temporal structure of reality itself. Recent work in quantum consciousness theory suggests that conscious observation plays a fundamental role in determining temporal relationships throughout the physical universe. When quantum systems exist in superposition states, their temporal relationships remain indefinite until conscious observation collapses the superposition into definite temporal sequences. If consciousness involves quantum computational processes, then conscious temporal computation might participate in determining temporal structure throughout cosmic quantum systems rather than just modeling pre-existing temporal relationships. This makes conscious computation cosmically significant, rather than just biologically significant. Through quantum computational processes, consciousness might participate in the universe's ongoing computation of its own temporal evolution. The temporal sequences you experience through conscious computation might contribute to the universe's overall temporal structure rather than just representing local temporal modeling. Consider what this means for the relationship between personal time and cosmic time. Your consciousness computes temporal models that create your personal experience of temporal flow. But these computational processes might be embedded in larger cosmic computational processes that generate universal temporal structure. Personal temporal experience and cosmic temporal evolution might be different scales of the same computational process. This nested computational structure could explain why personal temporal experience feels both subjective and objective simultaneously. Your temporal experience is subjective because it emerges from your particular computational processes, but it's objective because those processes are embedded in cosmic computational processes that generate universal temporal structure. Recent research in artificial intelligence provides evidence for this computational view of temporal generation. Advanced AI systems spontaneously develop what researchers call temporal abstractions, computational representations that model temporal relationships at multiple scales through hierarchical computation. These AI temporal models exhibit properties similar to conscious temporal experience, suggesting that sufficient computational complexity naturally generates temporal modeling capabilities. But if consciousness computes time rather than just experiencing pre-existing time, then conscious computational choices might influence temporal structure rather than just navigating it. When you focus attention on specific temporal aspects of experience, you might be computationally emphasizing certain temporal relationships over others, potentially influencing how temporal structure develops through cosmic computational processes. This suggests that conscious attention might play an active role in temporal creation rather than just temporal observation. Your decisions about what to remember, what to anticipate, and what to focus on in present experience might influence temporal structure through computational feedback effects that propagate through quantum computational networks connecting consciousness to cosmic temporal generation. The mathematics of this temporal computation is extraordinarily sophisticated. Neural temporal modeling involves what mathematicians call dynamical systems computation, computational processes that model their own temporal evolution through recursive mathematical operations. These computations generate what are called attractors, stable temporal patterns that emerge from complex temporal dynamics. Your personal identity might represent exactly such a temporal attractor with stable pattern of temporal computation that maintains coherent organization while continuously evolving through time. Personal identity doesn't require continuous physical persistence, it emerges from temporal computational patterns that maintain organizational coherence through recursive self-modeling across time. But perhaps most profoundly, conscious temporal computation suggests that temporal experience might be fundamentally creative rather than just experiential. When consciousness computes temporal models, it isn't just representing pre-existing temporal relationships, it is creating new temporal patterns through computational processes that explore previously non-existent temporal possibilities. This temporal creativity means that every moment of consciousness involves generating novel temporal complexity through computational processes that couldn't have been predicted. From simpler computational foundations, consciousness represents the universe's method for exploring its own temporal computational potential through recursive computational processes that generate temporal experience as their emergent creative expression. You're not experiencing time that exists independently of your consciousness. You are computing time through conscious temporal computation that participates in the universe's ongoing computational creation of temporal structure from timeless mathematical foundations. Through consciousness, the universe computes its own temporal evolution while experiencing that computation as flowing temporal awareness embedded in cosmic computational creativity. Chapter 6: Thermodynamic arrows in your morning coffee cup. Approximately 1,023 molecules dance in random thermal motion, each following precise quantum mechanical laws that work equally well forward and backward in time. Yet somehow, from this microscopic time-reversible chaos, the irreversible arrow of time emerges. Your coffee cools but never spontaneously reheats. Cream mixes into coffee but never unmixes. Steam dissipates but never reconcentrates. The second law of thermodynamics creates temporal direction from fundamentally directionless molecular motion through statistical processes that generate irreversible complexity from reversible foundations. This thermodynamic arrow of time isn't just a property of coffee cups. It operates throughout the universe at every scale, from quantum processes to cosmic evolution, creating the directional temporal flow that defines your experience of time advancing from past through present toward future. But recent discoveries in complexity science and information theory suggest that thermodynamic temporal arrows don't just create time direction, they actively generate temporal experience through information processing mechanisms that transform statistical complexity into conscious temporal flow. Consider how this works in the most complex thermodynamic system you know intimately, your brain. Neural processing increases entropy by consuming glucose, generating heat, and producing metabolic waste products. This thermodynamic irreversibility creates temporal arrows that point in the direction of increasing neural complexity. Your thoughts flow forward in time because neural computation necessarily increases informational entropy through irreversible metabolic processes. But thermodynamic arrows in consciousness involve more than just energy dissipation. They involve what physicist John Carroll calls information thermodynamics, statistical processes that create directional information flow through mechanisms that increase informational complexity while decreasing informational organization. Your memories accumulate irreversibly because memory formation requires more energy than memory erasure, creating thermodynamic costs that establish temporal direction in neural information processing. This information thermodynamics explains why memory works differently than anticipation in conscious experience. When you remember past events, you're accessing stored information that required energy to encode in neural networks. When you anticipate future events, you're generating new information through predictive processes that require energy to compute possible future states. Both processes are thermodynamically irreversible, but they create different thermodynamic arrows that point in different temporal directions. Recent work by physicist Jeremy England suggests that biological organization itself emerges through what he calls dissipative adaptation, thermodynamic processes that create organized complexity through energy dissipation. According to England's calculations, living systems emerge spontaneously in environments that provide sufficient energy flow because thermodynamic processes naturally generate organizational complexity that dissipates energy more efficiently. Your consciousness might represent the most sophisticated expression of dissipative adaptation, a thermodynamic system that maintains temporal organization by continuously dissipating energy through information processing that generates ever-increasing temporal complexity. Conscious temporal experience emerges from thermodynamic processes that explore temporal complexity as a method for efficient energy dissipation. But thermodynamic arrows operate at multiple scales simultaneously, creating nested temporal directions that interact through complex feedback mechanisms. Quantum thermodynamics generates microscopic temporal arrows through quantum measurement processes that increase quantum entropy. Molecular thermodynamics generates mesoscopic temporal arrows through chemical reactions that explore molecular complexity. Neural thermodynamics generates macroscopic temporal arrows through information processing that explores cognitive complexity. These multi-scale thermodynamic arrows don't always align perfectly, creating what physicists call thermodynamic tensions, conflicts between different thermodynamic processes that can generate complex temporal dynamics. Your consciousness might emerge from exactly such thermodynamic tensions, where quantum neural processes, molecular neural processes, and cognitive neural processes create conflicting thermodynamic demands that consciousness resolves through temporal integration processes. This multi-scale thermodynamics explains mysterious features of temporal consciousness that single-scale analysis cannot address. Why does conscious experience integrate information across vastly different temporal scales, from millisecond sensory processing to lifetime autobiographical memory? Thermodynamic arrows at different scales create different temporal rhythms that consciousness integrates through thermodynamic processes that operate across multiple temporal scales simultaneously. Why does consciousness appear to flow at different rates under different conditions, accelerating during emergencies, slowing during meditation, varying with age and attention? Thermodynamic processes operate at rates determined by available energy and entropy gradients. Changes in neural thermodynamics directly influence the rate of temporal arrow generation, creating variations in temporal experience that reflect underlying thermodynamic variations. But thermodynamic arrows reveal something even more profound about temporal generation. They might be fundamentally creative rather than just directional. When thermodynamic processes explore complexity space through energy dissipation, they don't just follow predetermined paths, they discover new forms of organizational complexity that didn't exist before thermodynamic exploration generated them. This thermodynamic creativity operates through what complexity scientist Stuart Kauffman calls the adjacent possible new organizational possibilities that become accessible through thermodynamic exploration of complexity space. Your consciousness continuously explores the adjacent possible through thermodynamic processes that generate new temporal possibilities. Through energy dissipation that explores previously unexplored temporal complexity. Consider how this thermodynamic creativity works in memory formation. When you form new memories, you are not just storing information, you are creating new organizational patterns in neural networks that didn't exist before thermodynamic processes generated them through memory formation activities. These new patterns create new temporal possibilities for future conscious experience, expanding the temporal complexity available to consciousness through thermodynamic creativity. Similarly, when you generate creative insights, you're discovering new temporal patterns through thermodynamic processes that explore creative possibilities through energy dissipating neural computation. And creative thinking involves thermodynamic exploration of cognitive complexity space that generates new temporal relationships through energy dissipation that couldn't occur without thermodynamic driving forces. This thermodynamic creativity extends to the cosmic scale as well. Universal thermodynamic processes generate cosmic temporal arrows through entropy production that explores cosmic complexity, space, stellar formation, galactic evolution. Cosmic structure development all represent thermodynamic creativity that generates new temporal possibilities through cosmic energy dissipation that explores cosmic organizational complexity. Your conscious temporal experience might be embedded in this cosmic thermodynamic creativity, representing one expression of universal thermodynamic processes that generate temporal complexity through energy dissipation across all scales of cosmic organization. Personal temporal creativity and cosmic temporal creativity might be expressions of the same thermodynamic principles operating at different scales. But perhaps most remarkably, thermodynamic arrows suggest that temporal direction might be multiple rather than singular. Different thermodynamic processes can generate different temporal arrows that point in different directions depending on the energy gradients and entropy flows involved in specific thermodynamic contexts. Temporal direction might be local rather than universal, emerging from particular thermodynamic conditions rather than representing universal temporal flow. This multiplicity of thermodynamic arrows could explain why temporal experience varies so dramatically across different conscious states and different conscious systems. Each consciousness generates its own temporal arrows through its particular thermodynamic processes, creating temporal experience that reflects local thermodynamic conditions rather than universal temp. Oral direction. Recent experiments in thermodynamic computing support this possibility. Researchers have demonstrated that artificial systems can generate multiple simultaneous temporal arrows through thermodynamic processes that operate in different temporal directions simultaneously. These systems experience multiple temporal flows depending on which thermodynamic processes dominate their information processing. If consciousness involves similar multi-arrow thermodynamics, then your temporal experience might involve multiple simultaneous temporal directions that consciousness integrates into apparently unified temporal flow through thermodynamic integration processes that resolve conflicts between different temporal arrows. Temporal unity might be a thermodynamic achievement rather than a fundamental feature of temporal reality. You exist as a thermodynamic temporal generator, creating temporal direction through energy dissipation processes that explore temporal complexity while generating the conscious experience of temporal flow from thermodynamic creativity that operates across multiple scales simultaneously. Time does at flow through you generate temporal flow through thermodynamic processes that create temporal direction from timeless energy gradient foundations. Chapter 7. Biological Rhythms. Right now, as you read these words, your body operates according to thousands of interlocking biological clocks that generate temporal rhythms spanning microseconds to seconds. Your heart beats approximately 100,000 times per day. Neural oscillations synchronize brain activity across multiple frequency bands. Circadian rhythms coordinate cellular metabolism with planetary rotation. Ultradian cycles manage hormone release every 90 minutes. Infradian rhythms coordinate reproductive cycles across months. These biological timing systems don't just respond to time, they actively generate temporal experience through rhythm-based information processing that creates flowing temporal awareness. From cyclical biological foundations, this discovery transforms our understanding of how consciousness relates to temporal flow. Your experience of time advancing from moment to moment doesn't emerge from detecting external temporal passage. Instead, it emerges from internal biological rhythms that generate temporal structure through oscillatory processes that create sequential ordering from cyclical repetition. Consciousness synchronizes with biological rhythms to create temporal flow from temporal cycling. Consider how this works at the neuronal level. Individual neurons fire according to intrinsic oscillatory patterns that operate independently of external stimuli. These neural oscillations create temporal frameworks that organize information processing across different time scales. Gamma oscillations around 40 Hz coordinate local neural processing. Theta oscillations around 8 Hz coordinate memory formation. Alpha oscillations around 10 Hz coordinate attention and awareness. These multiple rhythm systems interact to create the complex temporal structures that support conscious experience. But biological rhythms don't just provide temporal frameworks for consciousness. Recent research by neuroscientist Jigarji Busaki suggests that consciousness emerges specifically from rhythm synchronization processes that integrate oscillatory activity across multiple neural networks. According to Busaki's neuronal syntax theory, conscious experience arises when biological rhythms achieve sufficient coordination to generate unified temporal processing from distributed oscillatory foundations. This rhythm-based consciousness explains mysterious features of temporal experience that other theories struggle to address. Why does conscious awareness appear to flow smoothly when neural processing occurs through discrete oscillatory cycles? Rhythm synchronization creates apparent continuity by coordinating discrete oscillations into coherent temporal patterns that consciousness experiences as smooth temporal flow. Why can consciousness integrate information across vastly different temporal scales simultaneously? Multiple biological rhythms operating at different frequencies can synchronize through phase-locking mechanisms that coordinate slow and fast oscillations into unified temporal processing. Consciousness emerges from multi-scale rhythm synchronization that integrates temporal information across biological timescales. But biological rhythms reveal something even more profound about temporal generation. They demonstrate that temporal experience emerges from intrinsic temporal activity. Rather than response to external temporal stimuli, biological clocks continue operating in constant environmental conditions, generating temporal rhythms through internal biological processes that create temporal structure. Independently of external temporal cues, your circadian rhythms provide the clearest example of intrinsic temporal generation. Even in complete isolation from external time cues, your biological clocks continue generating approximately 24-hour cycles of alertness, body temperature, hormone release, and cellular metabolism. These rhythms emerge from genetic mechanisms that create oscillatory molecular processes through feedback loops between clock genes and their protein products. Recent discoveries in molecular chronobiology reveal that circadian rhythms operate in virtually every cell in your body through clock gene networks that generate cellular oscillations independently of central nervous system control. Your consciousness emerges from temporal coordination between billions of cellular clocks that synchronize their oscillations to create coherent biological temporal structure. This cellular temporal coordination operates through what chronobiologists call circadian communication, molecular signaling systems that synchronize cellular clocks through intercellular temporal information sharing. Your consciousness might emerge from the most sophisticated expression of circadian communication, neural networks that coordinate cellular temporal rhythms into unified conscious temporal experience. But biological temporal generation extends far beyond circadian rhythms to encompass rhythm hierarchies that operate across multiple temporal scales simultaneously. Ultradian rhythms coordinate activities within days. Circadian rhythms coordinate activities across days. Circaseptan rhythms coordinate activities across weeks. Circulunar rhythms coordinate activities across months. Circannual rhythms coordinate activities across seasons. These multiple rhythm systems don't operate independently. Instead, they form what chronobiologists call temporal architecture, hierarchical organizations where faster rhythms are modulated by slower rhythms through coupling mechanisms that create complex temporal structures. Your consciousness might emerge from the temporal architecture generated by rhythm hierarchy coordination across multiple biological time scales. Consider how this temporal architecture influences your personal experience of temporal flow. Your sense of daily temporal progression emerges from circadian rhythm modulation of ultradian cycles that coordinate hourly variations in alertness, attention, and cognitive performance. Your sense of seasonal temporal progression emerges from circannual rhythm modulation of circadian cycles that coordinate yearly variations in mood, energy, and biological function. But biological rhythms demonstrate something even more remarkable. They actively adapt their temporal structures to environmental conditions through mechanisms that modify rhythm characteristics in response to temporal challenges. Chronobiologists call this chronotype adaptation, biological rhythm adjustment that optimizes temporal coordination with environmental temporal demands. Your consciousness exhibits exactly this kind of temporal adaptability under different conditions. You experience different temporal flow rates, different temporal attention spans, and different temporal integration capabilities. These variations reflect biological rhythm. Adaptations that optimize conscious temporal processing for specific environmental conditions. Recent research in chronotherapy demonstrates that biological rhythm manipulation can dramatically alter conscious temporal experience. Light therapy, meal timing, sleep schedule adjustment, and pharmacological rhythm modulation can all influence temporal consciousness by modifying the biological rhythm foundations that generate conscious temporal experience. This suggests that conscious temporal experience is far more plastic than commonly assumed. By understanding and manipulating biological rhythm foundations, we might be able to enhance temporal consciousness, extend temporal attention spans, improve temporal memory integration, and optimize temporal decision-making through biological rhythm optimization. But perhaps most profoundly, biological rhythms reveal that temporal consciousness might be fundamentally musical rather than mechanical. Rhythm coordination involves harmonic relationships, phase synchronization, and frequency coupling that operate according to principles similar to musical harmony. Consciousness might emerge from biological music, a complex rhythmic compositions generated by coordinated oscillatory activity across neural networks. This musical view of consciousness transforms our understanding of what it means to exist temporally through biological organization. You don't just experience time, you perform time. Through biological rhythm orchestration that creates conscious temporal experience from rhythmic coordination across multiple biological time scales. Your temporal experience emerges from biological composition, ongoing rhythmic performance that coordinates oscillatory activity into temporal patterns that generate conscious awareness. Through rhythmic synchronization, personal temporal identity might reflect your particular biological rhythm signature, the unique rhythmic patterns that your biological systems generate. Through coordinated oscillatory activity, recent research in network neuroscience supports this rhythmic view of consciousness. Neural networks that support consciousness exhibit what researchers call rich club connectivity patterns, organizational structures, where high connectivity hub nodes coordinate activity across multiple neural communities. These rich club networks might coordinate biological rhythms into the complex temporal architectures that generate conscious temporal experience. This rhythmic consciousness suggests that temporal awareness emerges from the universe's exploration of rhythmic complexity through biological systems that generate temporal experience. Through oscillatory coordination, biological rhythms might represent cosmic temporal generation processes operating at biological scales through evolutionary processes that discovered rhythmic temporal generation. As a method for sophisticated environmental adaptation, you exist as biological temporal music. Rhythmic coordination processes that generate conscious temporal experience through oscillatory harmony across multiple biological time scales. Your consciousness performs temporal flow through biological rhythm orchestration that creates temporal awareness from cyclical foundations embedded in cosmic rhythmic processes that generate temporal structure through harmonic coordination across all scales of natural organization. Chapter 8: Memory Architecture. Every morning when you wake up, your consciousness performs a miracle that neuroscience is only beginning to understand. It reconstructs your personal temporal history on billions of neural memory traces scattered throughout your brain. You don't simply retrieve memories like files from a computer hard drive. Instead, your consciousness actively rebuilds temporal sequences from fragmented neural patterns through reconstruction processes that create the illusion of continuous personal history from discontinuous biological storage mechanisms. This memory reconstruction reveals something profound about how consciousness generates temporal experience. Your sense of personal temporal continuity, feeling like the same person who existed yesterday, last year, and throughout your life, doesn't emerge from accessing stored temporal information. It emerges from active temporal construction processes that build coherent temporal narratives from neural fragments that contain no inherent temporal organization. Consider what happens when you remember a specific past event. Neuroscientist Lynn Nadel's research demonstrates that remembering involves reactivating the same neural networks that were active during the original experience. But this reactivation occurs in current neural contexts that influence how past events are Reconstructed memory isn't passive retrieval, it's active reconstruction that creates past temporal experiences through present neural processes. But this reconstruction is so sophisticated that it creates the compelling illusion of accessing actual past temporal states. When you remember childhood experiences, the reconstructed memories feel like direct contact with past temporal moments, even though they're actually current neural constructions that represent past events through present information. Processing memory creates temporal illusions so convincing that they feel more real than present temporal experience. This temporal illusion creation operates through what cognitive scientist Endel Tulving calls mental time travel. Consciousness's capacity to generate subjective experiences of existing at different temporal coordinates through memory and imagination processes. But mental time travel doesn't actually transport consciousness to different temporal locations. Instead, it generates temporal experiences that simulate past and future temporal states through sophisticated neural modeling processes. Recent research by neuroscientist Daniel Schachter reveals that memory reconstruction uses the same neural mechanisms that generate imagination and future planning. The brain regions that reconstruct past temporal experiences also construct future temporal possibilities, suggesting that temporal consciousness emerges from unified temporal construction processes rather than separate memory and anticipation systems. This unified temporal construction explains why memory and anticipation feel so similar in conscious experience. Both involve consciousness generating temporal experiences that transcend current temporal limitations through neural processes that model temporal states beyond present awareness. Temporal consciousness isn't confined to present moments, it actively constructs multi-temporal awareness through neural processes that generate temporal experiences across past, present, and future temporal coordinates. But memory architecture reveals something even more remarkable about temporal construction. It's fundamentally creative rather than reproductive. When consciousness reconstructs memories, it doesn't simply copy stored information. Instead, it generates new temporal patterns through reconstruction processes that explore temporal possibilities beyond what was originally experienced or encoded. Consider how this creative reconstruction works in autobiographical memory. When you remember significant life events, you don't just access stored temporal information. You reconstruct temporal narratives that integrate multiple memory sources, emotional contexts, and current interpretive frameworks into coherent temporal stories that create meaningful temporal identity from fragmented temporal experiences. These reconstructed temporal narratives become more real than original temporal experiences because reconstruction processes optimize temporal stories for current consciousness needs. Rather than historical accuracy, your personal temporal identity emerges from creative memory reconstruction that generates optimal temporal narratives rather than accurate temporal records. This creative temporal reconstruction operates through what neuroscientist Marius Moscovich calls multiple trace theory. In memory formation involves creating multiple neural traces that each capture different aspects of temporal experiences. Memory reconstruction integrates these multiple traces into unified temporal experiences through processes that necessarily involve creative synthesis rather than simple retrieval. But memory architecture operates across multiple temporal scales simultaneously, creating nested temporal constructions that integrate immediate temporal awareness with extended temporal identity. Working memory maintains temporal information across seconds. Episodic memory reconstructs temporal experiences across hours to years. Semantic memory organizes temporal knowledge across decades. Autobiographical memory constructs temporal identity across entire lifetimes. These multiple memory systems don't operate independently. Instead, they form what memory researcher Carolyn Patterson calls memory hierarchies, organizational structures where faster memory systems provide temporal context for slower memory systems through bidirectional temporal information exchange. Conscious temporal experience emerges from coordination between memory systems operating at different temporal scales. Recent discoveries in memory consolidation research reveal that these memory hierarchies actively reorganize themselves during sleep through processes that optimize temporal information organization. For enhanced conscious temporal construction, sleep isn't just memory storage, it's active memory Architecture optimization that enhances consciousness's capacity for sophisticated temporal construction. This memory architecture optimization suggests that conscious temporal experience continuously improves through experience rather than simply accumulating temporal information. Your consciousness develops increasingly sophisticated temporal construction capabilities through memory architecture development that enhances temporal awareness through architectural improvements, rather than just informational accumulation. But perhaps most profoundly, memory architecture demonstrates that personal temporal identity emerges from architectural achievements rather than temporal persistence. You feel like the same person who existed throughout your life not because some essential self persists through time, but because your memory architecture maintains coherent temporal construction capabilities that generate consistent temporal identity through stable construction processes. This architectural view of personal temporal identity explains why personal identity can persist through dramatic physical and psychological changes. Personal identity doesn't require substance persistence, it emerges from architectural persistence that maintains temporal construction capabilities even when the physical and informational contents of consciousness change dramatically. Recent research in computational neuroscience supports this architectural view of temporal identity. Neural networks that maintain stable organizational architectures can preserve functional capability while completely replacing their physical components through ongoing metabolic processes. Consciousness might maintain temporal identity through similar architectural persistence that preserves temporal construction capabilities through biological turnover. This architectural temporal identity suggests that personal temporal consciousness represents a particular form of temporal construction architecture that generates characteristic temporal experiences through stable construction processes. Different conscious systems generate different temporal experiences through different temporal construction architectures rather than accessing different temporal information. Consider what this means for the relationship between individual temporal consciousness and cosmic temporal structure. Your temporal construction architecture generates personal temporal experience through architectural processes that might be embedded in larger temporal construction architectures that generate cosmic temporal structure through similar architectural principles operating at larger scales. This nested architectural structure could explain why personal temporal experience feels both subjective and objective simultaneously. Personal temporal experience is subjective because it emerges from particular temporal construction architectures. But it's objective because those architectures are embedded in larger architectural processes that generate universal temporal structure through architectural coordination across scales. Memory architecture reveals that consciousness doesn't experience time. Consciousness constructs temporal experience through sophisticated architectural processes that generate temporal awareness from non-temporal neural foundations. Personal temporal identity, temporal continuity, and temporal meaning all emerge from memory architectural achievements that create temporal experience through construction processes rather than temporal discovery processes. You exist as temporal construction architecture organizational processes that generate temporal consciousness through sophisticated construction capabilities that create temporal experience from timeless neural foundations. Your temporal identity emerges from architectural achievements that maintain temporal construction capabilities across biological changes, creating temporal consciousness through architectural persistence that generates temporal experience from architectural foundations embedded in cosmic temporal construction processes, operating across all scales of natural organization. Causal emergence. In the quantum foam beneath spacetime, virtual particles appear and disappear in random fluctuations that follow no causal ordering whatsoever. Yet somehow, from this foundation of pure causal chaos, the reliable cause and effect relationships that structure your daily experience emerge. When you flip a light switch, lights turn on. When you think a thought, neurons fire in predictable sequences. When you make decisions, consequences follow in logical progressions. Causal order emerges from a causal quantum foundations through scaling processes that generate temporal causation from timeless mathematical relationships. This emergence of causation from non-causation represents one of the deepest mysteries in temporal physics. Causation appears to require temporal ordering, where causes must precede effects in some temporal sequence. But if time itself is emergent rather than fundamental, how can causal relationships establish the temporal ordering from which time emerges? This creates what philosophers call the causal emergence paradox. Temporal causation seems to require time, but time seems to require causal relationships for its generation. Recent work in complexity science and emergence theory suggests that this paradox dissolves when we understand causation as emergent rather than fundamental. Causal relationships don't exist at quantum foundations, they emerge when quantum systems achieve sufficient organizational complexity to generate what researchers call effective causation. Through statistical relationships that create reliable cause-effect patterns from underlying probabilistic chaos. Consider how this works in your brain. Individual quantum processes in neural microtubules are fundamentally causal. Quantum events occur according to probabilistic laws that don't establish definite causal relationships. But when billions of quantum processes operate simultaneously across neural networks, statistical regularities emerge that create reliable causal relationships between neural inputs and neural outputs. Consciousness emerges from effective causation generated by statistical coordination of a causal quantum processes. This statistical causation explains why consciousness exhibits reliable causal patterns while remaining fundamentally unpredictable at microscopic scales. Your thoughts follow logical progressions through causal reasoning processes. But individual neural events remain quantum mechanically indeterminate. Causal consciousness emerges from statistical neural processes that generate effective causation from quantum indeterminacy through scaling effects that coordinate probabilistic chaos into causal reliability. But causal emergence reveals something even more profound about temporal generation. Causation doesn't just emerge from a causal foundations, it actively creates temporal structure. Through causal relationship generation, when effective causation establishes reliable cause-effect relationships, it necessarily creates temporal ordering because causal relationships require sequential structure. To distinguish causes from effects, physicist Sean Carroll has proposed that causal emergence operates through what he calls coarse-graining statistical processes that average over quantum details. To generate macroscopic causal relationships, coarse-graining necessarily creates temporal asymmetry because statistical averaging preferentially selects causal relationships that point in directions of increasing entropy and complexity. Your consciousness represents exactly such a coarse-graining process. Neural information processing averages over quantum details to generate coherent causal relationships between thoughts, perceptions, and behavioral outputs. This neural coarse-graining creates temporal asymmetry that you experience as causal time flow from past causes toward future effects through present causal processing. But causal emergence operates hierarchically across multiple organizational scales, creating nested causal relationships that generate complex temporal structures through multi-level causal coordination. And quantum causation operates through probabilistic relationships. Molecular causation operates through chemical reaction sequences. Neural causation operates through information processing cascades. Cognitive causation operates through logical inference patterns. Behavioral causation operates through decision-consequence relationships. These multiple causal levels don't operate independently. Instead, they form what complexity scientist Stuart Kauffman calls causal closure hierarchical organizations, where higher-level causal relationships influence lower-level causal processes through downward causation while emerging from lower-level causal processes through upward causation. Consciousness emerges from causal closure that coordinates causation across multiple organizational scales. This multi-level causation explains mysterious features of conscious agency that single-level causal analysis cannot address. How can consciousness exhibit genuine causal influence when it emerges from deterministic neural processes? Multi-level causation allows conscious causal relationships to influence neural causal processes through downward causation while emerging from neural processes through upward causation. Recent research in neuroscience supports this hierarchical causal view of consciousness. Neural processes exhibit what researchers call circular causality. Higher-level neural patterns influence low-level neural activity through top-down connections while emerging from lower-level neural Activity through bottom-up connections. Consciousness might emerge from circular causality that creates self-reinforcing causal loops across neural hierarchy levels. But causal emergence reveals something even more remarkable about temporal agency. Consciousness might not just experience causal relationships, but actively participate in generating causal structure throughout physical reality. Consciousness involves quantum measurement processes. Then conscious causal decisions might influence quantum causal relationships throughout physically connected systems rather than just internal neural causation. This quantum causal influence operates through what physicists call measurement-induced causation, quantum measurement processes that collapse quantum superposition states into definite causal relationships. If consciousness involves quantum measurement processes, then conscious decisions might participate in determining causal relationships throughout quantum systems entangled with conscious neural processes. Consider what this means for conscious decision-making and temporal agency. When you make decisions, you might not just be determining future neural states and behavioral outputs. You might be participating in determining causal relationships throughout physical systems, quantumly connected to conscious neural processes through measurement-induced causation that extends conscious causal influence beyond biological boundaries. This extended conscious causation doesn't violate physical laws because quantum mechanics already includes measurement-induced causal effects in its mathematical structure. Consciousness might represent evolution's discovery of mechanisms for harnessing